Has the world an origin? Was the hen first or the egg first? Many modern scientists believe that the universe originated from a cosmic egg by a catastrophic explosion called Big Bang. They rule out its creation by God. On the contrary, many religionists believe that, originally, God created the world. The question is, which one of these two hypotheses is more rational? Can any one of these be sustained on the basis of reason or scientific proof? Was the universe created at some point of time, or it is eternal? Over the past 2 millennia or more, man has been concerned with the great mysteries of existence. He has formulated many theories to answer this question: how and when did this universe or the world come into existence? Most of the major religions also have tried to solve this cosmic riddle in their own respective way. Over the last 4 or 5 centuries, astronomers, astrophysicists and geologists also have tried to tackle this question in their own typical ways and have formulated many theories, or better, call them hypotheses, because, actually, these have not yet attained the status of theories. We will discuss here only the most popular and most fashionable or current theories of origin, to see if these have satisfactorily solved the question. Big Bang Theory. One of the 2 most popular theories, mentioned in science books, was first proposed by the Belgian astronomer Georges Edward Lemaitre. In the year 1927, he suggested that, at a point of time in the remote past, there existed only one large lump. At that point of time, call it zero time, the matter and energy of the universe were literally squashed or compressed together into one huge mass, perhaps no more than a few light years in diameter. He called that huge mass the cosmic egg because, according to him, the cosmos was born out of it. Lemaitre said that this zero time, when the egg exploded, refers to a point of time about 2 billion of years ago, but, since geologists considered the Earth to be older than 2 billion years, some cosmologists, later, raised this figure to 5 billion and, subsequently, to 13 billion years ago. Isn't it look like a joke? Originally, the matter, which formed the cosmic egg, was hydrogen gas. Hydrogen atom is made of 2 particles only. There is a central proton, carrying a positive electric charge, and there is an outer electron carrying a negative charge. As long as these subatomic particles exist separately in the atom, there is a limit to which a mass of hydrogen gas can be compressed. But when the critical pressure is surpassed, the electron and proton in every atom of hydrogen gas may be considered to have been squashed very hard or condensed very densely together, so as to form a mass of electrically unchanged particles, called neutrons. Such a mass of compressed neutrons is also called neutronium. It would have a density of 1 quadrillion grams per cubic centimeter and would be far denser than any known thing, for this is the ultimate limit in compressing that can be reached, and, at this stage, the mass of matter becomes unstable. Now Lemaitre says that, at zero time, the densest and unstable cosmic egg exploded in what we can now only imagine having been the most gigantic and catastrophic explosion of all time. Sir Arthur Eddington, a famous English scientist, adopted and popularized this hypothesis, and, later, Russian-American astrophysicist George Gamow upheld and propagated it enthusiastically. It was Gamow who gave it the name Big Bang Theory. According to this theory, the fragments of that catastrophic explosion, which were sent hurtling out in all directions, became the galaxies. Not only did portions of the cosmic egg form the present-day galaxies, but, on a more subtle level, the cosmic egg broke up to form various atoms and 102 elements we know today. But, here we will not consider whether the theory, concerning the formation of all the 102 elements from original hydrogen or neutronium was possible. We will only consider whether the formation of cosmic egg and its subsequent explosion or Big Bang and the consequent formation of galaxies from it was possible as it is explained in science books. Does this theory or hypothesis solve the question of origin? On reading this Big Bang theory, one is bound to ask, but where did the cosmic egg come from? Which hen laid this egg? And whether that hen was first or the egg was first? In other words, how did hydrogen or its electrons and protons or neutronium originate? To answer this question, scientists take refuge in the concept of eternity and in the law of conservation of mass and energy. They say that the matter, making up the cosmic egg, was always there because matter is eternal and is always conserved, it never gets annihilated. Well, let us take it for granted that matter, forming the cosmic egg, was always there, the crucial question is whether the matter was there in the form of the cosmic egg. If one says, yes, it was always in the form of cosmic egg, then one would like to ask, in that case, the cosmic egg should have remained stable in that form for there was nothing else there to disturb it. Why did it suddenly, at zero time, cease to be stable? What led to its explosion after billions of years of stability? What were the forces which, originally, had been keeping it stable, and what new forces now, suddenly, brought about the explosion? Scientists have no satisfactory answer to these questions, on which depends the validity or credibility of this theory. Is the scientists' answer satisfactory? No doubt, scientists have tried to solve these and such other problems, but the question is whether these have been satisfactorily answered to give it credibility. A much too common answer the scientists give is, before the cosmic egg came into existence, there was an exceedingly thin gas. This gas had its own vastly diffused gravitational field. Gradually, over billions of years, the gas collected and the mass of the gas grew close together. As the substance of the universe grew more compact, the gravitational field became more intense until, after many billions of years, the universe went on contracting at a greater and greater speed. In this process of contraction, it produced higher and higher temperature as the gas compressed into smaller and smaller volume. This temperature rise increasingly countered the gravitational contraction and began to slow down the process of contraction. However, the inertia of matter kept it contracting more and more, till it was past the point where the temperature effect had just balanced gravitation. Finally, the universe contracted to a minimum volume, represented by the cosmic egg. At some point, the outward push of the temperature and of radiation finally overcomes the gravitational force, and this builds up into a force that results in the Big Bang. In this view, the cosmic egg becomes a momentary object. How the cosmic egg was first formed. Now let us read again the italicized lines above and think over them, keeping in view Newton's first law of motion, which states that everything keeps in its state of rest or motion unless there is an external force which is applied to it. The question is, since there was nothing else besides the thin gas, what led the gas to collect and to draw close? Since the force of gravitation was the same as it had remained for billions of years, how did it increase so as to contraction of the gas substance? According to the first law of conservation of mass and energy, the total mass and energy in the universe remain the same, they neither increase nor decrease. So, the question is, what additional force or energy outside the gas mass originally led the gas particles to draw closer and closer? No scientist, to this day, has solved this riddle. Moreover, none has ever stated specifically the actual size of the cosmic egg, or its total mass, or the force of explosion that rent it into fragments so that its pieces hurtled away and managed to attain the escape velocity to form galaxies. Also, the question is, if the cosmic egg hurtled its segments to form galaxies, wherefrom did the matter in the space between these galaxies come? Further, the universe being infinite or of very vast expanse, did the hydrogen gas fill the whole universe, or the thin cloud occupied only a part of it? If it filled a part of it, why did it occupy only that much space that it did? And how did it originally have only that much density or thinness and neither more nor less? If it filled an infinite space, how could, then, its so weak gravitational field, especially at its farther parts, lead it to contraction? Another question is whether the parts of the cosmic egg that hurtled out and formed galaxies will continue receding from each other forever, or their velocity of recession will slowly decline with time and will reach a momentary zero mark. And, then, will the galaxies finally begin to come together again, slowly at first and then more and more rapidly, and will, finally, condense to form something like the cosmic egg, constituted of hydrogen again? Following the formation of the cosmic egg, will there be another Big Bang, and will the whole process start over again, in the fashion of the egg giving birth to the hen and the hen laying an egg and the egg again breaking to give birth to another hen, the series extending to infinity? If the relationship between the cosmic egg and the universe is as between an egg and a hen, then, where is the question of origin or the beginning? Where is the irreversible change and the final ending? As the universe is right now, so will it be again an indefinite or infinite number of times, each time after an explosion, according to this theory. Thus, it fails to explain any origin in the actual meaning of the term. Steady-state theory. Certain astrophysicists, such as Hermann Bondi, Thomas Gold and Fred Hoyle, considered Big Bang to be impossible. They adopted, after some modifications, a new model of universe, suggested by an English cosmologist Edward Arthur Milne. Milne assumed that the general scheme of appearance of the universe would be the same from any point in space from where an observer saw it. An observer may be on any galaxy. From there he would find all the galaxies distributed symmetrically about him in all directions. He would find the general density of matter also the same everywhere. He would find himself at the center of an observable universe. He termed this concept as the cosmological principle. The cosmological principle seems to require an infinite universe, for otherwise you could not imagine yourself at its center by being anywhere. If the universe were finite, you could imagine yourself transported to its very edge and, from there, you would find all the galaxies on one side and nothing at all on the other. Einstein also assumed only one aspect of the cosmological principle when he considered that matter was distributed evenly in the universe, but he considered the universe to be finite, though the finite universe could have, in it, infinite galaxies. But a concept of an infinite universe following the cosmological principle could not fit well with the notion of the cosmic egg as possessing a finite size and as exploding into infinite number of galaxies. So, what was the solution to this problem? The scientists got stuck at this point. It would be interesting to know that George Gamow was ready to consider the cosmic egg as of infinite size. But how could then other postulates, such as the extensive gas cloud, etc., fit well with this theory? As a way out, Hermann Bondi, Thomas Gold and Fred Hoyle favored the cosmological principle, but they thought that it was incomplete. For, while it allowed the universe to be unchanged with the observer's position in space, it did not say anything about his position in time. So, these three scientists believed it logical to suppose that the universe would have to be essentially the same for observers at all times as well as in all places. They termed this the perfect cosmological principle. But, we can all see the universe changing in two important aspects. Firstly, the distance between the galaxies is growing steadily larger, for the galaxies are receding. So, an observer, say, 2 billion years afterwards, would not see the galaxies where we see them today. Secondly, hydrogen in the stars is steadily fusing into helium and other complicated atoms, so it means that a time will come when all hydrogen gas will get converted into helium. At least, in these two aspects, the universe cannot be considered steady. These 2 points are strong evidence against the perfect cosmological evidence proposed by these three scientists. To remove this lacuna, these four-named three astronomers advanced a solution in the year 1948. They suggested that hydrogen was continually being created out of nothing. They called this the continuous creation theory, or the steady-state theory, by assuming that, by the time a galaxy will recede into oblivion, another galaxy in its place would have come up and, by the time some hydrogen would be converted into helium, an equal quantity of hydrogen would have been created, out of nothing, mark the words out of nothing, to take its place so that, to an observer, the universe would always look to be steady or in a steady state. Is this theory scientific and rational? According to the first law of thermodynamics, which is also called the law of conservation of matter and energy, the total quantity of matter and energy in the universe remain constant. In other words, no more can be created so as to be added to it, nor can any part of it be destroyed to be lessened from it. Over and above this, the assumption that hydrogen is being continually created out of nothing seems to be ridiculous, utterly unscientific and against man's rational sense. It seems to be like a tale of magic or a fairy tale. How something could be created out of nothing? Bhagavad Gita also emphasizes upon the truth of the law of conservation when it says, "A thing cannot be created out of nothing, nor can that which exists be annihilated out of existence." But, indeed, it is strange that the proponents and protagonists of this theory say that hydrogen can be created out of nothing. Then any other thing also could come out of nothing. The above-named astrophysicists say that the law of conservation of mass and energy is merely an assumption based on the fact that mankind has never observed energy to be created out of nothing. They say that the requirements of the continuous creation theory, or steady-state theory, are very small indeed, for the creation of even one atom of hydrogen per year in 1 billion liters of space is enough. They say that creation at this rate will be too small to be detectable by any instrument man possesses. Obviously, they want to change the law of conservation from energy cannot be created to energy has never been observed to be created. Note the change in the wording and the resulting meaning. They do not want to answer the question, how can hydrogen or any other thing be created out of nothing? They sidetrack a very important and fundamental law without any verifiable evidence and a laboratory proof. The real issue involved is not whether a small or a big quantity of matter can be created or not, nor the issue is whether the rate of creation is small or great. The very solid issue, it must be noted, is whether something can be created out of nothing. By accepting this proposition, science would change into fantasy or fiction. Again, they say that the law of conservation is merely an assumption based on the fact that mankind has never observed, note the words, never observed, energy to be created out of nothing. In fact, this comment applies to their theory, for that is based on mere assumption and no one has ever observed something being created out of nothing. Moreover, the question of creation raises so many other questions connected with it, such as, who creates it? How does it get created? And where from does the energy required for carrying out the act of creation come? All these questions in regard to creation of hydrogen are left unanswered. Furthermore, the theory of Hoyle et al. Does not solve the problem of origin of the universe and the galaxies and of hydrogen even if this last be assumed to have been formed out of nothing. Another unproved assumption. Besides the arbitrary assumption that hydrogen is being continually created out of nothing, there is another assumption of the scientists who propounded the steady-state theory. It is that the galaxies are separating or receding from each other not as a result of some explosion but as a consequence of some more subtle effect. Scientists Hermann Bondi and Raymond Arthur Lyttleton assumed that the positive charge on the proton might be very slightly larger than the negative charge on the electron. They thought that if the positive charge of the proton were larger only by a billionth of the size of the electron's negative charge, it would suffice to build up a generally positive charge on all galaxies but, because of being too small, it would not be detectable even by the most sensitive of instruments that man now has. This positive charge on all the galaxies, they thought, would cause the galaxies to repel each other and, thus, would cause them to undergo a steady mutual recession. As has been pointed out earlier, these scientists have said, in regard to their first assumption, that the rate of creation of hydrogen would be so small that man, with the best available instruments, will not be able to observe it. And now, in regard to the positive and negative electric charges also they say that the difference would be so small that, with the best available instruments man would not be able to observe it. Is this a scientific way to get a theory accepted? This is exploitation of man's weak position because of lack of extremely sophisticated instruments in this field. Simply because man would not be able to detect it, therefore, they want him to accept it. Strange. The theory should stand on firm grounds. As admitted by them, this assumption also is not based on any observation as to the positive charge being slightly greater than the negative charge. This is just a speculation so as to replace the unbelievable Big Bang theory. Further, as said earlier, Hoyle and other scientists say that, by the time the present galaxies have receded outside the visible universe, new galaxies would have appeared in their place. These new or young galaxies would have been formed from the hydrogen created continually, out of nothing. And, so to an observer, the universe would always look to be the same. It would not look empty because of some galaxies having receded out of view because, by the time the old galaxies disappeared, the new ones would have appeared, in their place. But, how hydrogen, created out of nothing, would condense and form galaxies? None of the scientists has explained this. Isn't this like counting the chickens before the eggs have been hatched? It would seem that the theory aims at an eternal universe in which things were not created in the remote past by a Big Bang but are being created continually. The Big Bang theory also, as shown earlier, leads to the concept of an eternal universe where a cosmic egg explodes into galaxies, etc., and where galaxies contract into a cosmic ball, and the cosmic ball explodes again to form galaxies and the universe. And, yet both these theories do not explain any origin, in real sense of the term. Why not, then, believe that the world is eternal and things are continually changing their form so that, after a cycle, they come back to have the form and the position from where they started? Would not that be more rational and more scientific, for we practically find this cyclic recurrence of the ecclesiastical phenomena and of many other natural phenomena. The world, in that concept, would be a cosmic drama which repeats itself after having occurred and reoccurred. It would thus be eternal. Astrophysicists and cosmologists are now coming closer to the belief that the world has no beginning. For example, Professor Giant V. Nadakar, speaking recently at the 10th annual meeting of the Astronomical the Universe Society of India, ruled out the concept of a beginning, commenting on the belief in the continuous creation out of nothing, on which steady-state theory rests. He presented the picture of cow and grass in a blank frame to ridicule such scientists. We quote him, "Out of nothing, these scientists said there was grass. When asked where was grass, they said the cow ate it. Asked about the cow, they said it was not there as the cow had already eaten the grass and gone." We will discuss more on this topic in upcoming series. So, stay connected with us, and of course if you have any question, you can post it in comment section.